Okay. Oh, we'll move back a bit. Can you all see?
Yes.
Yep. Okay. Now, what exactly is surds? So, firstly, surds is anything that can be written like this, really. You know, this is what I call a surd. Here, this is called the square root. I know in some countries people call this a radical, or radicals. Those would probably be the American educated students, American system. So anyways, here, UK and Ireland, called surds or square roots, okay?
Never be called radicals.
Or radicals, yeah. All is fine. So, I should actually also say that you need the C not to be a square number. So, C is not a square number. So, for example, 2 plus 3 root 2 would be 1. Or even just the root by itself, for example, root 10. Or, for example, 2 root 7. These are all examples of surds. So first thing is you need to know this word. And it's important for the exam because I've seen them use this word a lot in the exam. They would say, write your answer as a surd, not a decimal. So you need to know what surd means. So this is surd form. Oh yes, write this down, yeah. Surd form. Important word. I'll say it again. You need to know this word for the exam. Okay? Yep. So what we're going to look at is some algebra techniques for dealing with surds. But just before we do that, a little bit of revision of something that I know you probably did in elementary school because I remember doing in elementary school. So cast your mind back, maybe when you were 12 years old. So the name here, or maybe if it was elementary school, you might have called it prime factor 3. Does this ring any bells for anybody? Anybody remembering this? So what you do, it's a way to change a number into prime numbers. And a prime number are special numbers because
they can't be divided.
They can't be divided by anything except 1 or itself. So let's take the number 50 as an example. So what you do is you pick any two numbers that multiply to make 50. 25 and 2. And then you see if you can repeat. I can't repeat with 2, right? So I'm finished with 2, so I'll circle that. Then I can continue with 25. What can I say? 5 times 5. So you get this result. 50 equals 5 times 5 times 2. So that's 2 times 5 squared. And this is called the prime factor form or the prime factorized form when you change 50 into this. And in fact, for what we're going to do today, this will be very useful technique. So if you can write this down. Now, am I right in saying you did this in elementary school? Yes?
Yes.
Okay. Next page? No? No. I'm recording it, so. Okay? Right. Now, how can we use this? So, let's look at our first example. I want to simplify square root 108. So, first, let's factorize our 108. So, 108 can be 54 and 2, and I'm done with the 2. The 54, again, that could be, for example, 2 and 27. I'm finished with the 2. The 27 could be 3 and 9. And the 9 could be 3 and 3. So I try to group this together as many squares as I can. So 108 equals, I have a 2 squared, don't I?
Yeah.
That's great. Now, I have 3 cubed. I won't actually write it as 3 cubed. I'll write it as 3 squared and another 3. And then what's left? Oh, is that it? That's it, yeah? Now, why did I do that? Well, the reason is because this actually has a square root on it. Whoops. And the square root cancels the squares. So in fact, I can cancel this square to leave me with a 2. I can cancel this square to leave me with a 3. But I can't cancel here. So I'm just left with a root 3. So this equals 6 root 3. And that's the simplified answer. That's as small as you can make it. Okay, write that example down, please. Okay. Looks like you all got that. So next example now. Example 2. You have root 624 plus root 39. And once again, the prime factor theorem is what we need to help us simplify this. So 624.
It's 3, 12.
6, 7, 8, 9, 10. Yeah, 3 goes into that. 3 times 208. Yes. Is
Why
that right?
not 2 times 3, 12?
Any pair is fine.
Oh, okay.
I just picked 3 because I saw 3 goes into this. Right, 3 is done. 208, okay, that's 2 times 104. Okay. 104, that's 52 times 2. 52.
That's 16.
20,
Sorry, 26.
26 times 2. Or 13 times 4, actually, I think would be better. Yeah, 13 times 4.
Yes.
13 is done. And then 4,
2.
2 times 2. So, if I try and get this all together, 624 equals, there's a 2 and a 2, so that's a 2 squared. There's another 2 and a 2, so that's a 2 squared again. And there's a 3, and there's a 13. So, root 624, what would that equal? 2 times 2 root 3 times 13. So that's 39. So that's 4 root 39. So write that down, please. Well, we can now answer the question because, I'll do it in red here. This equals 4 root 39 plus 1 root 39. That will equal 5. root 39. Do you need me to scroll down? And I'll scroll back up in a minute.
Why did you remove the square?
Where?
2 square.
Oh, because the square root removes the square.
The roots remove the square.
Yes.
How did you cancel those two?
I didn't cancel, I just was counting them. You mean the 2's at the bottom? Yeah, no, that's just me counting. So I wanted to make sure I got all my numbers.
The example is
2a. I'll go back up.
Sure, do we need to make
and
those
then we do the
that tree?
39.
Huh? Oh yeah, you see the first one, root 624, I worked that out to be 4 root 39. So 4 root 39 plus 1 root 39 will be 5 root 39. I didn't need to do anything to this, it's already fine. All I'm doing is the same thing as the first example, factorizing my number to simplify it. Yeah?
Is that the final answer or that?
In red is the answer. The red.
Oh.
Okay, can I?
Sure.
One. So. By the way, if you type in root 624 on your calculator, see what you get. This is the Casio 991 people at least.
4,
Yeah.
It's the same, isn't it? Now, in the exam, listen, in the exam, you don't need to show the workings here with the tree. So you could just go from root 624 to 4 root 39. Okay? But what you can't do, and you'll get 0 marks, is just type the question in. Because if you type the question in, so type that in root 624 plus root 39. It'll come out on the calculator as 5 root 39, I think. Yes?
Yeah.
What you can't do is this. You'll get 0 marks if you do that.
So where does 39 go?
So what you need to do is you need to show that you at least are aware of the fact that the root 624 has to be simplified into 4 root 39. And this is the process to simplify it.
Do we do all these steps in the exam?
No.
Without calculator?
No, that's what I'm saying. You don't need to draw the tree.
Simplify the bigger number. And
No, sometimes you need to simplify both.
yeah.
Okay. So example 3. I'll do the second one. So I'll do 7 minus 2 root 5, 6 minus 6 root 5. So this is actually just a multiplication. First by first, first by second, second by first, second by second. So 7 by 6, 7 by 6?
So 42.
2, yes. 7 by 6 root 5 with the minus is minus 42 root 5. Minus 2 root 5 by 6 is minus 12 root 5. And then be very careful at the end here, okay? The last one. Root 5 by root 5 is 5. Yeah, it's 5. 5 by 6 by 2 is 60 in total, I think. 2 times 6? 12.
Well,
And then multiply by 5?
60.
60. So in fact, at the end, you don't get any roots. You just get a 60. So 42 plus 60, 102. Minus 42 root 5, minus 12 root 5, minus 54 root 5. And that's the answer. Yes? I'm going to do another example here, but this time I'm going to do the last one, z. Root 8 plus root 3 times root 2 plus root 48. Alright, so first thing, what do you think is the first thing you need to do? No. Simplify first. So root 8 would be 2 root 2, I believe. Yes. Root 3 is root 3. Root 2 is root 2. And root 48, what's that? 4 times 12, which is 4 root 3?
4 root 3.
Come on, you all have calculators in front. If you don't make your teacher do all the work. So what's root 48?
4 root 3.
Which is what I said, yes, okay. 4 root 3. Okay, now we multiply out. So what would be 2 root 2 by root 2? It'd be 4, very good. 2 root 2 by 4 root 3. Well, 2 by 4 is 8. So that's 8. But root 2 by root 3 is root 6. It doesn't simplify because they're different numbers. You see? If this was a 2 and a 2, then you'd have root 2 by root 2 is root. Root 2 by root 2 is 2. Alright, root 3 by root 2?
Is root 6.
Root 6. And then root 3 by 4 root 3?
12.
12. It's 4 by 3. So that's 16 plus
7, sorry.
9
root 6.
root 6. Scroll up, there. Yes? Is that what you need?
Yeah, that's right.
So can we do everything on calculator or doing?
No marks for that. You can check the answer though. Okay, can I go to the next example? Yep. Now, example 5. I want you to look in your book and can you underline in question 4 the phrase rationalizing the denominator? This is a technique that could be in the exam. They could say rationalize the denominator. So you need to know that vocabulary. So underline that, rationalize the denominator. Now what does that mean? It's a way of simplifying fractions. So let me show you how it works. So how does rationalizing the denominator works? Well, what you do, yes, go on, multiply by what?
By the dominator.
The minus 2.
By
Plus
3.
Minus 2 plus 2, what have we decided on?
Minus 2.
Minus 2
Plus root 3.
Plus
minus root 3.
minus
Yes, now, that is very important. There's a name for that when you change the sign in front of the root. Does anybody know it?
To eliminate.
Yeah, you need to change the sign to eliminate this, but there's a name for this.
because of the root.
Oh yeah, no, but I'm looking for the noun, the name, the word that describes this here. Changing the sign on the root.
rationalizing.
No, rationalize is a verb. I want the noun. All right. Conjugate. This here is called the conjugate of this, which simply means the same thing but change the sign on the root. So you multiply the top and the bottom by the conjugate of the denominator. And again, the conjugate of the denominator just means the denominator with the sign changed on the root. Yes? So rationalize is the verb, and to rationalize means to multiply the top and bottom by the conjugate of the denominator. What's the name of the top line called?
Dominator.
No.
Numerator.
Numerator. Denominator. Numerator. Denominator. Okay. Now, before I go ahead, can somebody just type in root 147, what's going to be 140, 7 root 3? 7 root 3.
Yeah.
Minus 10 plus 7 root 3 times minus 2 minus root 3 all over minus 2 plus root 3 minus 2 minus root 3. So I've changed this division problem into 2 multiplications. So we'll multiply them now. So a little bit of help here. On the top I get 20 plus 10 root 3 minus 14 root 3 minus 7 root 3.
Well, why do you get 7? Don't you already get?
Thank you. Yeah, it's not 7 root 3. Sorry, what's it? It's 7 times 3, 21. Okay. And on the bottom, you get 4 plus 2 root 3 minus 2 root 3 minus 3. Now this is the great thing about rationalizing the denominator. What happens is the roots always cancel. If they didn't cancel, it means you made a mistake. So this here didn't happen by accident. This should always happen. So what am I left with in the denominator?
4 minus 3.
Just 1. So what am I having in the numerator? I have minus 1, 20 minus 21, and then 10 root 3 minus 14 root 3?
4
Minus 4 root 3. So we've changed surd over surd into a surd. Wrote that down? Okay, let me tell you which ones to do so you can circle these. Number 1 is page 19. Number 1, B, C, D. B, C, D. In number 2, let me check which ones. I want you to do K, E, X, and R. Yes. Yes. In number 3, I want you to do, let me see, nice one. Well, when I did said, so, X and Y. And then finally, number 4, W, X, and Y. Okay, you can start those now.